Hi, I'm Conduant, and I'm the president and a co-founder of Conduant Corporation. In this video, I'd like to give you a brief introduction to our PXI Express storage products. Conduant originally developed our PXI storage products as a necessary component for our StreamStore Cobra high-speed recording systems. The PXI Express platform allowed us to design a modular recording and playback system with configurable channels, capacity, and performance. For the storage component of these systems, we needed PXI Express NVMe solid-state storage, so we designed our own storage boards. These storage boards are used to stream data to and from our recorder FPGA boards using peer-to-peer data transfers. These storage products also provide a great platform to meet general-purpose requirements, whether it is to meet a need for additional storage capacity or for streaming data from system memory when the performance of the StreamStore recording system is not required. PXI Express systems are an excellent choice for many system applications to combine various sensor I/O boards, analysis boards, storage, and software to support applications in test and measurement, radar, RF, electronic warfare, and numerous others. The Conduant storage products provide a reliable and high-performance addition to these systems. Originally designed for test and measurement applications, PXI Express systems provide an ideal platform for these applications due to its industrial design, numerous card slots, shared clock and trigger signals, as well as front panel access to all connections. This Keysight chassis can hold up to 17 boards in addition to the system controller that provides the connectivity and capabilities of a high-performance computer. These systems are also available with ample power supplies, offering up to 85 watts of power to each slot with forced air cooling across every board. PXI Express systems usually include an in-chassis controller such as this Keysight M38A shown here. This Keysight controller includes all the most useful computer resources, including Thunderbolt and 10 gigabit Ethernet. Additional capabilities can be added by installing boards from the wide range of available PXI Express boards, including the Conduant storage modules and FPGA boards. The Conduant PXI Express storage boards provide a high-performance storage option using NVMe drives. The NVMe drives use solid-state flash memory and employ a direct connection to the PCI Express fabric. This eliminates the conversion from PCI Express to older storage protocols like SATA or SCSI used by hard drives of the past. This board is an M.2 carrier board which supports up to 4 NVMe solid-state drives with total capacity up to 16 terabytes. The 4 drives on the board can be combined into a striped array for high-performance reading and writing. The drives illustrated here are enterprise-class drives that provide enhanced performance and reliability with a total storage capacity of 15.2 terabytes. Many different drive options are available with capacities up to 16 terabytes total. The large heatsink, in combination with the chassis direct airflow, helps to prevent these drives from throttling performance during long sustained write operations. We also offer a U.2 SSD carrier module that can accommodate a single NVMe solid-state drive. The drive is easily removable from the front panel for applications that require the data to be removed for security or other reasons. Various capacities are available up to 15.2 terabytes, including a non-removable 30 terabyte option. There is also an option that utilizes an internal M.2 drive for applications that insert or remove the drive frequently. This technique isolates the drive connector from wear to protect the data from becoming inaccessible due to connector failure. Installing one of our PXI Express storage modules is fairly straightforward, and I'll run through that with you now. Okay, I have a couple storage modules here. This first one is a DM4 M.2. It has 4 M.2 NVMe drives installed. These are 1 terabyte drives. So we'll just pick a slot, slide the board in. I usually try to push at the top. Once it feels seated, we use the handle and a little pressure on the top to seat the board fully in until the handle clicks in place. This board is one of our removable U.2 modules. In this case, this one has an M.2 inside a carrier. The reason for that is the M.2 connector is not being inserted and deinserted every time you remove the drive. That way, if the connectors ever wear out, we're only replacing the low-cost carrier or this board. We never put the connector on the storage device itself at risk. Slide it in, a little pressure on the top, seat the handle, and we're good to go. Okay, now that the system is up, the first step is to start the disk management tool. The easiest way to do that, right-click on the Start menu, select Disk Management from the menu. That will start our disk management tool, as you can see here. I will expand this a little bit, make it easier to see. And what we have, we start with the 1 terabyte drives. You can see there's 1, 2, 3, 4. Now sometimes if these drives have not been previously configured, this tool will prompt you to select either MBR or GPT for the boot record. If they're coming from us, they will generally have already been selected as GPT, and you won't need to do that step. In order to create a striped array, I'm going to select the first of these 4 disks. I'm going to right-click in this area and select New Striped Volume. Select Next. Now I've got the first disk already selected. It's the one that I right-clicked on. I need to select the other 4 and add them to the selected side of this menu structure. So I'll add, it goes to the next, add, and add. This last one is the M.2 drive installed on the other board, so we're not going to include that in this case in our striped array. As you can see, we can determine how much of each disk we want to use for the total capacity. The total is shown here. If I want to use all of it, I just take the defaults, select Next. I can assign it to a drive letter. In this case, I'll go ahead and allow it to use drive D. Next, we recommend that you perform a quick format. There's no reason to do the longer format. And then we'll set a volume name. For now, I'm just going to call it array. And we'll call it 4 by 1, meaning 4 by 1 terabyte. It'll show you here the things that you've selected to make sure you've got everything that you want correct, and then finish. This is warning you that you're converting these from basic disks to dynamic disks. Just hit yes here. And within a few minutes or a few seconds, depending on how quick your system is, you have a new drive, drive D. You can see it showing up here. There's the name that I gave it. We can look at the properties and see that we've got about 4 terabytes of capacity. These were 4 1 terabyte drives.
Now we'll use Crystal Disk Mark and show the performance of this striped array with 4 by 1 terabyte drives. We'll modify the settings a little bit. Use the demo mode and run a sequential read and write. In the profile demo, we'll switch to 8 queues and 8 threads with a 1 megabyte block size. Again, sequential read, sequential write. We need to change the folder to the D drive that we created and start the test. It starts by preparing, essentially creating the file on the drive. Now it's performing the read. We're going to get a little over 7 gigabytes per second. Now we're preparing a file for the write and performing the write. And we also get a little over 7 gigabytes per second.
About the limit that you're going to see on a Gen 3 8-lane wide interface that we're using in this case. I'm going to stop that. We're going to configure now the U.2 drive, very similar to what we just did. Make this a little bigger. You can see that that disk is down here. I'm going to select that. I only have one drive available that's not configured, so the only choice is a simple volume. It's very similar to the striped array. We can define how much of the disk we want to use, assign it a letter, or you can assign it something in the NTFS file system for where to mount. I'm going to hit next. We'll call this our U2 removable. Hit next. Oops, let me go back for a second. Make sure my perform quick format is on. Next, check to make sure everything's correct, and then finish. And now we have the new disk, which we assigned E. So we'll run a quick performance on that. Select the E drive here.
And we'll start the test, performing a sequential read. We get a little over 3.5 gigabytes per second on the read. Preparing for the write. And we get around the same for the write. As a side note, I should also point out that a longer write will not be able to sustain this data rate going to a single drive.
Thanks for watching, and be sure to take a look at the Conduant PXI Express FPGA boards if you have a need for high-speed signal processing or data transfer.